So in this lesson, we're going to go over rigid motion and corresponding parts of congruent triangles. This is AKS IOA Big Idea 3, using congruence criteria for triangles to solve problems and improve relationships. We are actually doing IOA 2D, explain how the criteria for triangle congruence follows from the definition of congruence in terms of rigid motions. And we're going to use congruency criteria for triangles to solve problems and to prove relationships in geometric figures. So today we will explore and justify triangle congruence criteria using rigid motion. So this first question here says, here are three triangles. Triangle PQR is congruent to which triangle, and explain your reasoning. So what we're going to do is we're going to kind of color code what we see here, okay? So the first thing I see is that I've got a 46.6 degree angle there, a 46.6 degree angle there, and a 46.6 degree angle there. Hopefully all of you see that as well. Okay, then I see this side right here that's 5.9. I see this side over here that's 5.9, and I see this side over here that's 5.9. So I'm going to go ahead and put a tick mark on that, a tick mark on that, and a tick mark on that, because we know that those sides are all the same length, right? Okay. Then I'm also going to, I see that this side right here is 4.3, and I see that this side right here is 4.3, and I see that this side right here is 4.3, okay? So, because of what we can see, and I want to point one other thing out to you. Do you notice that this 46.6 is across from, actually let me put that in a different color so you guys can see it. The 46.6 is across from the 4.3, the 46.6 is across from the 4.3, the 46.6 is across from the 4.3. This is all relevant information, right? So we can then use that to write a statement. So if we're wanting to know triangle PQR is our middle triangle here, right? So it says triangle PQR. So what does that mean we're doing? We're going from the angle right here, right? We're going from our red angle right there. Y'all see that angle? We're going from that red angle across the green side and then across the blue side. So we want to do that with the other one too. So if we start with the red over here, so we're talking triangles here. So triangle A, we start with red. We said we went across the green, right? And then, which was C, and then we ended with the blue. So that was ACE, right? Okay, then over here, again, we're going to start at the red where the angle is. And so that's our M, go across the green, that's N, and then across the blue, which was L, okay? Now, again, we could have also put two tick marks on this side and two tick marks on this side and two tick marks on this side. And again, it would have helped us even more, right, to orient ourselves, because we would have been going from red to one tick to two ticks. Got it? We also did this by color, so it helps, okay? Then it says, show a sequence of rigid motions that take triangle PQR to that triangle. Well, if we're looking at what would the rigid motion be to take us from this one to that one, it looks to me like, let's think, yeah, both of them would be a rotation, right? Wouldn't it? So it would be pretty easy to do a rotation. So what is the different types of rigid motion? Let's talk about that right now. So we have translations, right? Translations are when we move left, right, or up or down, right? Then we have reflections, and that's when we're reflecting over some line, right, of some sort. And then we also have rotations, okay? So what type of transformation does not produce a rigid motion? That would be a dilation, right? Dilations are when something gets bigger or smaller, okay? So our next part here says what types of rigid motion occur in the images below. So example 1, this says, are the two triangles congruent, okay? So what I noticed first is that we have a right angle at angles T, right? Y'all see that? So there's angle T equals 90 degrees, okay? Then let's see if we can count these sides. So ST is 1, 2, 3, ST prime is 1, 2, 3. Y'all see that? So ST equals 3, which is equal to ST prime, right? Okay. Then if I count RT, it's 1, 2, 3, 4, right? And RT 1, 2, 3, 4, right? So RT is also equal to 4, and RT prime is equal to 4, right? Okay. So what does that mean? Obviously, that means that the hypotenuses would have to be the same length as well, wouldn't they? So, yes, these triangles are congruent. The answer is yes. Why? Because we've got really 3 sides and a right angle that are congruent, okay? Then the next, example 2 says triangle ABC is congruent to EFD. I want to point out to y'all that this is wrong. It should not be EFD. It should be EDF. Okay, so let's change this. This should be triangle EDF. Now, how do I know that? So we got that right angle right there and this right angle right here, right? We can all see that. So look at, we got a short side, right there, and a short side there. We've got a long side and a long side, and then we've got a hypotenuse and a hypotenuse. Y'all see that? So the reason why I know it should be EDF is we start at A here at the end of that 1 tick side. We start here at the 1 tick side, and we're going towards the right angle, right? B is the right angle. So that's why this should be EDF. And it says, what rigid motions take ABC to EDF? Select all true statements after the transformations. Now, if we look at the rigid motion here, I would say that it looks to me like it was rotated. And then it was translated, okay? A rotation, I think all of y'all can see the rotation, right? But if we were to rotate it just around this point B right here, it would be tipped, right, to the left. And then we would have to move it right and up, wouldn't we? So it would also be a translation. It would be both. Those are the rigid motions that occurred in that transformation. So then it's to select all the true statements after the transformations. So it says angle A coincides with E. A coincides with E. Yep, that's a true statement, right? Okay. Angle B coincides with F. B and F, no, because those are both right angles, right? So that one's definitely not true. Segment AB coincides with segment EF. AB is the short side. EF is not, so that's never not a true statement again. BC coincides with DF. That's going from the right angle across the 2-tick side, and again from the right angle to the 2-tick side. So that's D is correct. AC, the hypotenuse, coincides with ED. No, again, the AC is the 3-tick side, and ED is not the 3-tick side, right? Because that's kind of what you're going to start doing when we do this, y'all. All right, so what types of rigid motion occur in the images below? So first it asks us, triangle ABC, what is it, what's it going to relate to? Okay, so A is down here, and then B, and then C. So I do notice that this is too tall, and this one right here is too wide, right? You guys see that? Okay, so I'm quite sure that those sides go together, but do you notice the smallest angle in here? I notice that this angle looks to me like it's going to be congruent with that angle, doesn't it? Because they are the smallest angles. So A relates to D, doesn't it? Okay, then if we go to B from there, A to B, that looks like the shorter of the 2 sides that are left, right? So I'm going to put a tick on this side, and A to B is there. So I think this is D to E. Don't you guys? Okay, and then the only letter that's left is F, right? Okay. And obviously E to F is the same thing as from B to C, because both of those sides are 2. So to me, again, this looks like a rotation. But again, if I were to rotate it, even if I were to rotate it from the center there, it's going to rotate. It would have ended up being these 2 points, right? 2, 2. Okay, so it's a rotation, and then I think it's also going to be a translation again. Rotation and translation. Okay, so this next one, again, I'm going to look at short side, short side. This one kind of looks like it might be a right angle. Not 100% sure, but I'm quite sure that that angle is going to be congruent to that angle. If they're asking us what rigid motion occurred, it's the same. The sides are going to be congruent and the angles are going to be congruent, okay? So let's see, that angle and that angle. So I'm just going to do my hypotenuse next. Hypotenuse, what I think is a hypotenuse, or the opposite of that angle. And then we've got this third side, right? And then this third side, okay? So it says again, L is opposite the 3-tick side. So we got Q opposite the 3-tick side. What do I mean by that? Look right here. If we look at L is right there. Y'all see it? So what's across from the 3-tick side right here? That's Q, right? Okay. Then if we start at Q and we go from L to M, that's our 1-tick side, right? So we're going from we're going from Q to R, right? So this would be R. Okay. And then obviously the only letter to this left is our S, right? So Q, R, S. Okay. Again, what do we think happened? It kind of looks to me like it reflected over the y-axis because it flipped, right? So it's a reflection, but if I just reflect it, then I think it's going to have to be a translation as well. And we're not concerned right now on details of how much. We could figure that out if they gave us choices, but okay. So that was your you do, sorry. And then the we do, ABC. So this one's a little harder, right? Okay, so let's again look at, I'm going to look at this short side and this short side, and the angle across from it would be A, right? And the angle across from that would be A. Then the challenge with this one is, well, it actually has the numbers on it, A, B, and ABC prime. So we don't have to really know that. So this is going to be A prime, B prime, C prime, right? So it's asking us what rigid motion occurred, right? So in this case, again, it looks to me like it rotated and then it translated some. Okay. Then you guys go ahead and do this last one and come back to me when you're done. So once again, I got a short side, a short side. I got what looks like a right angle and what looks like a right angle, right? Then I have a longer side and a longer side and what looks like a hypotenuse and what looks like a hypotenuse, right? So here we started with A, so there's our arc side, so that's going to be D, right? And then we went across the 2-tick side. So we're going to go across the 2-tick side. So that's E. And then we're going to finish with F. Okay. So what do you think happened on this one? Sure enough, looks like a reflection, doesn't it? That's all it looks like on this one. It looks like some sort of reflection like through there, right? Because we got C and F, right? And we got E and B, and we got A and D. Okay. All right, so the next part of the lesson is we're going to talk about geometric figures are congruent if they are the same size and shape. Key here, they got to be the same size and the same shape, okay? Corresponding angles and corresponding sides are the same position in polygons with equal number of sides. So two polygons are congruent polygons if and only if their corresponding sides and angles are congruent. Thus, triangles that are the same size and shape are congruent. So corresponding sides are sides that are congruent and in the same position. Key phrase there, position, okay? Corresponding angles that are congruent and occupy the same position at each intersection of a pair of congruent sides. So these are your blanks. Pause here and go ahead and fill them in. All right, so we're going to work through this diagram right here to talk about these properties. So the first thing we're going to talk about are angles, okay? So notice that A right here has, so angle A is going to be congruent with angle D, right? Angle D, okay? We can tell that because they both have one arc, okay? Then we can look at angle B, right? Angle B is congruent with what angle? Angle E, right? Okay? And then angle C right here, 3 arcs. Angle C is going to be congruent with angle F, right? Now, also this statement, notice first letter, second letter, or middle letter, last letter, last letter. This is going to become very relevant when we move forward. Okay, so when we start talking about our sides, we're going to go from A to B, which is across our one tick side, and we're going from 1 arc to 2. So we're going to say AB is congruent with, again, going from 1 arc to 2, DE, right? Okay, then we're going to go across our 2 tick side, so we're going to say BC right here. So this is going to be BC, and we're going from 2 to 3. So we're going from 2 arcs to 3 arcs right there, so that's going to be EF. And then our third one is going to be CA, so that was from 3 arcs to 1. So CA, and so here again we're going from 3 arcs to 1, 3 arcs to 1 right there, right? So that's going to be FD. Those are our congruent statements. Now notice too, again, A maps to D, B maps to E, C maps to F, and that should always be true. Okay, so on this next one, remember what I just said. P is going to map to S. So if we start talking about angles, angle P is going to be congruent to angle S. Start Q and then T. Angle Q is going to be congruent to angle T. And then R and W. So angle R is going to be congruent to angle W, right? Okay, now we're going to talk about sides. So right here, our first 2 letters, PQ, is going to be congruent with our first 2 letters, ST. Then I'm going to erase this. And then we're going to do our next 2 letters. QR is going to be congruent with TW. And then we're going to do first last, okay? Or last first. Doesn't matter which way we go, okay? So this, if we go first last here, that's PR. Right? And that's going to be congruent to first last there, which is SW. Now, the other thing you can do here is draw the shape, okay, and start labeling it. But I like doing it this way because you can see where things go relative to the other triangle, just by the order, okay? So go ahead and do this next one. Come back to me when you're done. So here again, angle A is congruent to angle G. Angle B is congruent, B and H. Angle H. Angle C is going to be congruent with angle I, right? Okay. Now I'm going to change it up just a little bit when I go through this next one, okay? So I'm going to say BA, BA, and so I'm going to say HG is congruent with HG. Y'all see what I'm doing? It doesn't matter which order I go, I'm still talking about the same side, okay? So here I'm going to say CB and IH. CB is congruent with IH, okay? And then this time I'm going to go last first, okay? So I'm going to say CA is congruent with IG. Okay? So go ahead and do this, you try, and then come back to me when you're done with that one. All right, here we go again. So we're going to do angle E is congruent with angle P. Whoops, forgot the angle sign. Angle P and angle F is congruent with angle Q. Angle G is congruent with angle R. And I'm going to go back to my real simple, straightforward first 2 letters. EF is congruent to PQ, because I'm sure this is the way most of y'all did it. Then we have our next 2 letters, right? So we're going to do FG. FG is congruent with QR. And then I'm going to do my first last. EG is congruent with PR. Okay? So now the next one says, given that triangle ABC is congruent to DBC, find the measure of DBC. So DBC is that angle right there, okay? So notice if this is right, then that's right, correct? Okay, so those are both right angles, and it says A maps to D, right? A maps to D. So that means this is going to be 49.3 as well, right? So to find the angle in question, can't we just do 90 minus the 49.3? We can. And so, what did I get? 90 minus 49.3 is 40.7. So the measure of angle DBC was equal to 40.7, sorry. 40.7 degrees, okay? All right, now I also want to talk to y'all about X, because sometimes we're going to ask you for that. So if I asked you for X, okay, then we're going to set this equal to 90, aren't we? So if we do 2x minus 16 equals 90, then we're going to add 16 to both sides. So that's 2x equals 106, and half of 100 is 50, and half of 6 is 3, right? So x is equal to 53. Okay? All right, go ahead and do this. You try. I'd like you to find x, b, c, and the measure of f. Pause and come back to me when you're done. So again, AB is congruent with what? AB is congruent with DE, right? So we're going to do tick, tick. So if we're trying to find x, right, can't we just say 2x minus 2 equals 6? Add 2 to both sides, right? So 2x equals 8, divide both sides by 2. So x is equal to 4. Then it says find BC. BC is here, so that's our hypotenuse, right, guys? So that I'm just going to do 2 ticks there because it's opposite the right angle. So this one's going to be opposite the right angle there. And we also know that BC maps to EF, doesn't it? Okay, so I'm going to do my 2 ticks here too. So it says BC is going to be equal to what? 10, right? Okay, then it says the measure of angle F. Okay, so what angle does F map to? So we got C there and F there, right? So what's our C down here? Well, we have to find it, right? So again, because it's a right triangle, can't we go 90 minus 53? So if we do 90 minus 53, isn't that going to be 37 degrees? And if C is 37 degrees, then what else is 37 degrees? F. So the measure of angle F is equal to 37 degrees.